All right, so this is the, yes, it is. I'm sorry for that interruption. So this is the second half of the calculator section of the 7th grade PARCC Mathematics Performance-Based Assessment. A scientist planted seeds in 4 sections of soil for an experiment. Not all the seeds grew into plants. After 20 days, the scientist counted the number of plants in each of the 4 sections. The results are shown in the table below. So we have the size of the section, and we have the number of plants. And then it says, use the data in the table to determine approximately how many plants grew per square foot. Explain or show how you determined your approximation, and let y be the number of plants expected to grow in x square feet. Write an equation the scientist could use to model the relationship between x and y. Enter your approximation, explanation, and equation in the space provided. Now this is a lot going into one math box. Well, the first thing I'm going to do is I'm going to pull up the calculator because I'm going to have to find a whole bunch of plants per square foot. And I just want to remind you that the word per is divide. So when it says plants per square foot, we're going to divide plants by the square foot. So let's go ahead and do that. So for section 1, we had 13 plants in 25 square. Nice. Let's start over again. I had 13 plants in 25 square feet. So that is 0.52 plants per square foot. And I'm going to record that. All right, so for the next one, I had 38 plants. 38, come on, 38 plants divided by 100. Come on, 38 divided by, now it's working. And that would be 0.38 plants per square foot. No name means no credit. So then we had 47 divided by 125 square feet. Oh God. 47 divided by 125. Hopefully the test works better than this. That's 0.376. And then finally, we had 62 divided by 150, and we get 0.413. And it's asking us to determine, using the chart, approximately how many plants grew per square foot. Now, I need to make a decision here, right? I have four sets of data points, and none of them are the same. We have 3 that are very close, and 1 that's kind of an outlier. So, I mean, you need to make your best determination. Obviously, you can find mean, or you can find the mode. It'd probably make a little more sense. So the mode of this data set would be, I'm going to add, I'm going to take my point, oh God, so 0.41 plus low plus, this is driving me crazy. And I'm going to add to it the third highest, 3.8. Okay, 0.41 plus, what's halfway in between these two? You know, it's going to be about 40. It's going to be about 40. So it'd make more sense just to round it to 0.4, right? So I can safely assume that my number of plants, y, is going to equal 0.4 times my square feet. And so I'm saying that for every square foot, I can assume that we're going to have approximately 0.4 of a plant. Now, obviously, you can't have 0.4 of a plant, but we're talking about on average. And my explanation on how I got that approximation is I found the plants per square foot for all 4 sections, and then I found a number that is in between the 4 of them, and I did kind of take out that outlier because it is so much greater than the other 3. It's kind of out on its own, and 0.4 seems reasonable, and so that's basically what I can write out on this problem. All right. So let's look at number 8. Consider the equation 5 plus x is equal to n. What must be true for any value of x if n is a negative number? Okay, so I know. So I should probably read the whole thing. Explain your answer, include an example with numbers to support your explanation. So I know that 5 plus x equals n, and n is negative. So what can I assume? Well, what is the smallest negative number I know? The smallest negative number that, well, does it say it has to be an integer? No, I could have a negative fraction. So what is the smallest number that does not fit into my data set? Well, what can n not equal? Well, I know n cannot equal 0. So I know that 5 plus x cannot equal 0. And so if I solve this, I minus 5, I get x must be less than negative 5. Can't equal negative 5 because that would give me an answer of 0. So what must be true for any value of x? X must be less than negative 5. And I would include this calculation here. And then for my example, I'd have 5, I would say let x equal negative 6. So I have 5 plus negative 6 equals negative 1. And that would pretty much do it. Next question, number 9. Anytime now? All right. So number 9 says, a worker has to drive her car as part of her job. She receives money from her company to pay for gas that she uses. The table shows a proportional relationship. When it says proportional, you think linear. Between x and y. The amount, y, the amount of money the worker receives, and x, the number of work-related miles driven. Okay, so then, and then question A says, explain how to compute the amount of money based and write your explanation, write an equation. All right, so this is a proportional relationship, which is just code word, excuse my yawn, for linear. And so for linear, I need to find my slope. Of course, PARCC wants to use constant of proportionality instead of slope, but there you have it. So obviously, we're going up by 10 here. Here we're going up by 5. Here we're going up by 10 again. And so the difference here is going to be, well, that's 10 cents. And that's $5.10. The difference here is going to be hopefully half of that. let's just bring this up, because I'm sure that you grab the calculator anyways. So we do 20 minus 0.4 minus 17.85. So we get a difference of, that's perfect because that's half, right? But we know that this is our rise, and we know that this is our run. Therefore, our slope is going to be our rise divided by our run. So I'm going to find my slope here. I'm going to say 2.55 divided by 5. And so that means that the worker gets 51 cents per mile. And in my explanation over in my box, anytime now, the explanation inside the box should have your rise and run calculation shown. You're going to have to spell out the rise equals 2.55, the run equals 2.55 divided by 5 is equal to 51 cents per mile. And so your equation is y is equal to 0.51 x. Well, I don't know, I've never had them. Thank you. Thank you, Marcy. So then, to go on, it says, based on your explanation, write an equation. Done that. So after you get your answer, you want to look at it. And so explain how to compute the money made by the worker. Okay, I verbally did that. I didn't do that in writing, but I'm assuming you would. Based on your explanation, write an equation. I did that. The worker receives and enter your explanation. Okay, so I did that. So it's always wise after you answer the question to go back and reread the question to make sure you answered what they were asking, actually asking. So for part B, it says, on Monday, the worker drove a total of 134 work-related and personal miles. She received $32.13 for the work-related miles she drove on Monday. This is going to be a nasty problem. What percent of the total miles driven are work-related? Okay, so the percent is going to be equal to the work-related miles divided by total miles. And to figure out the work-related miles, I know that she gets y equals 51 cents times x, right? And it tells us that she got $32.13. So $32.13 is going to be equal to 0.51x. So then it's time for me to do some division, because what's the opposite of multiplying the number of miles by 0.51? It's dividing by 0.51. And so I'm going to pull up my calculator again. Where'd it go? All right, so I'm going to bring it over here. So I have $32. Now it works too well. Now it doesn't work well enough. $32.13. I really do want a 1 anytime. I'm going to divide it by 0.51. So she went 63 miles for work. So that means she went 63 miles for work. She had a total of 132 miles. So that means she's had a total of, gotta carry that. So there's 71 miles that were not work-related. But does that really matter? No, because we have work-related miles over total miles, right? So our work-related miles is 63 divided by 134. And so let's go ahead and use my calculator to figure that out. So I have 63 divided by 134. Oh, come on. Ain't technology great. 63 divided by 1. Come on, 1. The 1 key doesn't want to work too well. 34. So that's 47%. So 47% of her miles are work-related. And so you need to show all your math work, plus give some explanation on what you did. All right. Problem number 10. Anytime now. All right, the graph shows the distance in miles, d. A car travels in t hours. And I can't see the whole thing, so that means I must scroll down. Explain why the graph does or does not represent a proportional relationship between variables. Okay. So here's the thing. Your graph is a straight line. So you know this is a linear equation. And you know that a proportional relationship is equal to a linear equation. And you know that because in a proportional relationship, you have a constant slope, or a constant of proportionality. And so in other words, your graph will always be aligned because you're moving at a constant rate. So what I would do is I'd find that slope. I'd find that constant of proportionality. So if I have a rise here of 100, and it's not 4, you got to see the value here, and a run of 2, that means my slope is going to be my rise divided by my run. And my rise is 100 divided by my run, which is 2. So my slope is equal to 50. Of course, I could also call that constant of proportionality, but write the whole thing out. And so I know this is a proportional relationship between d and t because for every 1 of d, my t increases by 50. And that's it. Last problem. All right. Ooh, exercising. We love exercising. All right. Sal exercised by stretching and jogging 5 days last week. He stretched for a total of 25 minutes during the week. He jogged for an equal amount of minutes each of the 5 days. He exercised for a total of 240 minutes. Elena also exercised by stretching and jogging 5 days a week. She stretched for 15 minutes each day. She jogged for an equal amount of minutes for the next 5 days, and she exercised for a total of 300 minutes. Okay. Determine the number of minutes Sal jogged each day last week and the number of minutes Elena jogged each day last week. All right. So, we know that for Sal, and everything that I write obviously should go in this text box. So we know that he had 240 total minutes of exercise, and he spent 25 of them stretching. That's 5 minutes a day. And so he had a total of 215 minutes jogging. All right, and it says determine the number of minutes he jogged each day last week. So then divide that by 5 because it was a 5-day week. So divide by 5. And so 5 goes into 21 4 times. Let's just write it out. So it goes in 4 times. Carry the 1. Goes in 3 times. So that's 43 minutes of jogging per day. It's not too bad. For Elena, on the other hand, she had 15 minutes each day. Well, that's a lot of stretching, my goodness. So 15 minutes of stretching for 5 days. So you multiply it out and you get 5, carry the 2. That's 75 minutes of stretching. No wonder she had so many more minutes than Sal. So let's figure out how much time she spent jogging for those 5 days. So we subtract it out, so we get 225. And now divide that by 5. So 5 goes into 22 4 times, carry the 2. So she jogged for 45 minutes per day. All right, and so let's double check. It says determine the number of minutes Sal jogged each day. Check that off the list, 43. And the number of minutes Elena jogged each day last week. Check that off the list. And show your work or explain it. So if I showed all of my work in an organized manner with explanations, I would probably be just fine on this problem.
Perfect.